We're going to hear from a guy called Dr. Todd Katzner, who unfortunately couldn't be with us, but I think he's coming in from, is he there? Is he coming in from Kazakhstan? Is that where you are, Todd?
No, I'm actually in Australia, in
Oh,
Tasmania right now.
okay. Same
So
thing. So I know Todd quite well, and I could spend this next few minutes telling you some funny stories about him, but I probably shouldn't. Uh,
good idea.
I might do that afterwards for those who are coming for drinks. Um, okay, let me tell you what it says here about Todd. Dr. Todd Katzner is a research wildlife biologist at the Snake River Field Station of the U.S. Geological Survey in Boise, in Idaho. He's more than 35 years of experience in the fields of ecology and conservation biology. He received his BA from Oberlin College, his master's from the University of Wyoming for research on pygmy rabbits, of all things, uh, and a PhD from Arizona State University for work focused on the ecology and conservation of eagles in the Republic of Kazakhstan. Todd was the first leadership trainee at Hawk Mountain, and he was here in 2003. We also co-authored and co-edited a book together called The Eagle Watchers, which came out in 2010. I'm not sure if you can still get it. You might be able to get it on Amazon. If you want to buy it, please do, because half of the proceeds from that book go to Hawk Mountain Sanctuary, because we were both interns here. So let me just introduce quickly Anna, although you've already met her, but not properly. So Anna is a forestry engineer who's made birding her career. She's monitored migrating raptors and conducted bird surveys while promoting conservation in her home country of Colombia. She serves on the board for Hawk Mountain and for the National Network of Bird Watchers in Colombia. She was a conservation science trainee in 1998. So I think we're going to hear from Todd first, and then Anna, and then I think there's going to be a wider discussion from all the speakers. So I'll hand over to you, Todd. Thank you.
Thanks very much, Ruth. And hello, everybody. I can't really see the audience, but I'm sure there's a lot of people who I would recognize. I'm really sorry I can't be there in person. I am in Tasmania on a Raptor project. We are studying wedge-tailed eagles here, and it's a neat opportunity. And the timing was kind of precise, and it didn't allow me to come to Hawk Mountain. But Laurie and Becca asked me to talk sort of about raptor conservation and key challenges and issues. And I realized, looking at the schedule, that it probably would have been good if I could have gone first at the beginning as sort of an introduction and background to this whole process. But it is 6:20 in the morning, and it would have been quite difficult for me to do this 6 hours ago. So you get me at this time. So I wanted to start off just with a little bit about myself. Ruth already introduced me and hit some of the key points. I was the first leadership intern at Hawk Mountain way back in 2003, right after I got my PhD. I'm now a research wildlife biologist for USGS. I'm one of 2 or 3 raptor biologists that they have. I do work primarily on raptors, but not only on raptors. And the work that I do is really global. I'm in Australia right now. I have an active program in Kazakhstan, and I'm supervising a student who's doing research in Spain. I've supervised a couple of students from the Philippines, both of whom have actually spent substantial time at Hawk Mountain as well. And a lot of the work that I do nowadays is focused on renewable energy impacts on wildlife, especially raptors, toxicology of wildlife, especially raptors, and demography, population ecology of birds. So I figured I'd start off by telling you a bit about just going over what a raptor is, right? Because if we're going to talk about protecting raptors, we kind of need to know what a raptor is. So generally, the thing that we all acknowledge about raptors is that they are aerial predators, and I think all of them are aerial. Not all of them are predators. Obviously, there's things like vultures and other species that don't really don't really kill a lot of food. Most raptors have raptorial features, right? So they have these big grasping feet. They have a sharp beak, and they have really strong eyes. Of course, that's not always the case. Especially things like the vultures don't have those feet that are so useful for predatory behavior. Taxonomically, we put raptors into generally one of four orders: the accipitriformes, which are the hawks and the eagles, and there's an African hawk eagle and an African fish eagle, and a Galapagos hawk in the bottom right. Those are accipitriformes. Cathartiformes are the North American vultures. So in the top right is a African vulture, but they're in the accipitriformes. The cathartiformes are the turkey vultures and black vultures that you can see at Hawk Mountain and things like the California condors. The falconiformes are the falcons, not really closely related to many of the other raptors, fairly distant, likely related to parrots. There's a lesser kestrel kind of in the middle of the screen. I took that picture in Kazakhstan. And then the strigiformes are the owls, and there's an owlet up in the top left that is a typical strigiform. One of the neat things about raptors is that the term raptor isn't really a formal taxonomic description. And so lots of other species get proposed as raptors or suggested as raptors. So people have talked about seriamas and shrikes and crows and ravens and jaegers and skuas, all as potential raptors, probably other species as well. So this group of raptors is something that is kind of nebulously described, but we also all kind of know sort of what we're talking about when we talk about raptors. So that's kind of what a raptor is. Why would we bother to conserve them, right? What makes them important? Well, when we think about raptors and when we think about them in a scientific context, we tend to think of them as either keystone, umbrella, indicators, or flagship species. And those are intuitive terms, but they may not have obvious meanings or obvious scientific meanings. In the case of raptors, they're apex predators, and that makes them a keystone, right? And a keystone is sort of like the Roman arch. It's that stone in the center. You take away the keystone, and the whole arch collapses, right? And so in theory, as an apex predator, if you remove the apex predators, then the ecological functioning of the rest of the system is going to be degraded or even break down. And in many cases, raptors are those keystones. The presence of raptors is associated with higher biodiversity than sites without raptors. And so this makes them an umbrella. And what I mean by umbrella is that if you're thinking about conservation, if you protect that umbrella species, then you're going to protect a whole group of species that are associated with that species. So if we protect the raptors, then we know that many of the species they prey on, many of the species they rely on, they're also going to be protected. And that's what we mean by calling them an umbrella. Raptors are indicators. And what that means is that they're reflective of ecosystem status and function. So if you have raptors, you probably have a healthy ecosystem. And if the raptors are doing well, that's a good sign. If the raptors are doing poorly, the ecosystem might not be doing that well. And finally, raptors are motivating for people, right? I've got a picture of a bald eagle here, and that's for the US, that's the national symbol. But if you go to countries all over the world, there are raptors that are on the flag, that are the national symbol, that have immense relevance. And that's true whether you're in Kazakhstan, where I do a ton of work, where an eagle is on the flag. It's true in Russia and Germany, in several parts of Central and South America. It's true in the Philippines, where the Philippine eagle is an icon. These are species that motivate people and that encourage them to do conservation and protect the environment. So I wanted to talk a little bit about the threats that raptors face, and that's actually going to be probably the bulk of what I talk about. And when we talk about the threats that raptors face, we tend to think about those threats in sort of two categories. There's natural threats and there's anthropogenic threats. And I'm going to step through some of these and give you some examples. On the right is an awful picture of a bald eagle that is facing an anthropogenic threat. Its foot is caught in a leg hold trap. That bird has been flying for days or weeks with that trap on its foot. It's scavenging at a deer carcass. I believe this is from Michigan. This is one of the anthropogenic threats that many raptors face. The threats raptors face are species specific, they're age specific, they're season specific, and they're geographically specific. And I'm going to try and talk a little bit about each of these specificities in the next couple of slides. When you think about threats, one thing that's important to understand is that most of the work that we do is focused on direct impacts or direct threats. And those are things that cause mortality, cause the animals to die. There's lots of other threats that are more insidious and that are harder to assess. And we don't focus on them as much, but they're really important. And I will briefly discuss them. So just a couple of examples of sort of how these threats break down and what these threats are. And the first of these examples is drawn from a study that I was involved in that looked at causes of death of golden eagles in the Western US. And what we saw was that the ratio of anthropogenic to natural threats varies over the life of the birds. And so I mentioned these threats were age specific. For first-year eagles, 75% of the mortalities are natural causes of death, right? Things like starvation, accident, disease, or fighting. So if you're a young eagle, you tend to die from natural causes before you die from other things. It's exactly the opposite for older eagles. Once you're an older eagle, only 25, 26% of mortalities are from natural causes. And in that case, the most common ones are accidents and then fights and disease and starvation. So if you're a young bird, starvation is the thing that really gets you. It's the most common cause of death for young birds. Once you've figured out how to be an eagle, then you don't really starve that much. But if you're going to die from natural causes, it's things like accidents or fights. But if you're an older eagle, anthropogenic causes of death make up, 74% of the mortalities in the population? And that's really important. And that has a big impact on the population. And the threats that are the most important to eagles, to golden eagles, the biggest one is shooting. Illegal shooting is the most common cause of death for adult golden eagles in the Western US. Excuse me, the most common cause of anthropogenic death. After that, we have collision, electrocution, poisoning, and being caught in a trap, like we saw with that bald eagle on the prior page. The picture in the top right is from a recent paper by one of my graduate students. This is a bald eagle, but the story is the same. Interestingly, on the left, you can see that bird was electrocuted, but when we did a radiograph of that bird, we also saw that it had been shot. And we're pretty confident that this bird was shot, and as it died, it managed to fall off the power pole it was sitting on and also get electrocuted. So that's an example where the primary cause of death was shooting, but this bird initially was thought to have been electrocuted because of the way it was found. On the bottom right is again another bald eagle. This bird is experiencing lead poisoning. And so these are just two examples of these types of causes of death. Another paper that I was involved in looked at causes of death of raptors in the African and Eurasian flyway. And this one just recently came out. And again, the story is really similar. And this, we didn't look at age-related causes of death quite as much, but if we looked at natural versus anthropogenic causes of death, and what we saw is that in terms of natural causes of death, for predatory raptors and vultures, natural causes of death only make up 30% of the recorded causes of death. So again, pretty similar to this 25% of adults that are dying of natural causes for golden eagles in the Western U.S. For predatory raptors, when we looked at anthropogenic causes of death, electrocution was the most common cause of death. Illegal killing was second, collision was third, and poisoning was fourth. And then after that, there was kind of a mix of categories. I mentioned earlier that anthropogenic stressors are species specific, right? Well, vultures are different than the other predatory raptors in terms of the threats they face. Poisoning in the African Eurasian flyway, poisoning is the greatest cause of death for vultures. And then after that is electrocution, illegal killing, and collision. So in case of vultures, there's a great deal of poisoning, especially in Africa, that is really affecting these birds, and it's a huge conservation crisis. So I said that there were species-specific patterns to some of these threats that raptors face. And just generally, if you're an owl, then you are threatened by rodenticides. And that makes sense because owls eat a lot of mice and things like that. And so many owls actually end up dying from rodenticide poisoning. Owls also die from vehicle collision. And we see that in a lot of different countries, particularly with species like barn owls, where vehicle collisions are a really important cause of death for that species. Scavengers, as I mentioned, scavengers face poisoning for eagles and for sort of seasonally for eagles in areas where there's a lot of shooting. Lead poisoning is a big deal. For vultures, particularly in Africa and South America and parts of Europe, pesticides are a big deal, and these are pesticides that are sprinkled on animals that are killed by mammalian predators. And the goal of this is to poison that hyena or that lion that might have killed a sheep or a cow. But there's all this secondary poisoning. So the pastoralist, the person who is responsible for those animals, might end up getting the lion or the hyena that killed their sheep, but may also kill 100 vultures or something like that. And that, as I mentioned, that's a really big problem. Pharmaceutical drugs are a big problem for vultures in South Asia and sometimes in a few other places. And then for diurnal predators, illegal shooting and killing is a big deal. Electrocution is a big deal. Vehicle collision is a big deal. And then, of course, you've got things like environmental toxicants, insecticides like DDT and rodenticides and flame retardants are one that we've been seeing recently is really common. I mentioned that there were age-specific patterns. Younger birds are more likely to die from natural causes. We've already seen that. Older birds are more likely to die from anthropogenic causes. something interesting is that older birds tend to accumulate toxicants. So you get lead that builds up in the bones of California condors, like these two condors in the bottom of the screen. And the condor on the left is an adult, and the condor on the right is a juvenile. But things like insecticides and rodenticides build up as these birds age and can potentially cause problems. And then the last thing we see is that older birds are far more likely to die in territorial fights, and that's obviously a natural cause. But younger birds tend not to be territorial, but older birds obviously are. So there are season-specific patterns that raptors face in some of these threats. During the breeding season, I mentioned fights over territories. During the breeding season, there's also this strong association with recreational shooting. In Western North America, there's a lot of ground squirrel shooting, and that tends to be associated with illegal shooting of raptors. During migration, raptors face threats from illegal shooting. You're at Hawk Mountain right now, and historically, Hawk Mountain was a place where there was raptor shooting. Obviously, that doesn't happen anymore, but at places like Batumi on the Black Sea and Malta in the Mediterranean, there is still ongoing shooting of raptors. And then during migration, there's also an added threat of avian influenza, which is one that's in the news a lot because it's economically important to people. On wintering grounds, raptors are trapped for food. We saw that from the Philippines. We've seen it in India. Raptors face lead poisoning from scavenging. Many species scavenge a great deal more in the winter and so are much more exposed to things like lead poisoning. And then in the Middle East, there's a great deal of trade in raptors that are wintering. And the awful picture on the right is a pile of eagles from a market in Baghdad. And these eagles were being sold for reasons because people like to buy them. There's a market for them. And those birds are all alive. And that's a pretty awful thing. I mentioned, all these things we're talking about are direct threats. There are also indirect threats to raptors. There's habitat loss and alteration. There's disturbance. There's climate change. This ridge line is Bald Eagle Ridge in central Pennsylvania. It's a few ridges to the west of where all of you are sitting. It's a gorgeous, gorgeous area. It's important for migration, much like the Kittatinny, and it is potentially threatened by all of these habitat loss and alteration, disturbance, and climate change. It's a nice example of one of these habitats that is so important to raptors. So that's kind of a gloom and doom, and it's a long list of all the threats that raptors potentially face. There are solutions. I mean, one of the really encouraging things is that there are solutions to all of these. And if you really want to address the causes of concern, the threats to raptors, the first thing we can do is focus on the anthropogenic causes of death, right? That's 75, 80% of the important causes of death for these birds. We know we can address illegal shooting. My graduate student who just finished a study on illegal shooting was able to document this, and as a result of the work that she did, there were arrests made, there was law enforcement action, there's been a great deal of outreach, and we think we've actually had an impact in reducing the amount of shooting in the area where she did her work. And her work is a great model for other places all over the world. Combinations of law enforcement and outreach, education, all of those things work well. And we saw that in the previous talk when there was an example from the Philippines. When it comes to poisoning, the two biggest toxicants that we think about right now are lead poisoning from use of lead ammunition and poisoning in Africa from use of vertebrate poisons, things to kill predators. Both of those are addressable, and there's efforts to do that right now, ongoing. In North America and in Europe, there are programs to reduce the use of leaded ammunition, and there are programs in Africa to build capacity and educate people and find alternative ways to protect livestock. We know that when it comes to electrocution, we can build and retrofit power poles correctly. We know when it comes to collision of raptors, we can do things like change roadside habitat, alter turbines, put flags on power lines. All of those reduce threats to these wildlife, to raptors. And then we know we can mitigate for indirect effects. So even though there's a long list of stuff, we know there are solutions to all of these problems. All of this requires changes in human behavior, but it's also, if it's underpinned by strong science, by education, outreach, and training, then these are achievable goals. And I think I just want to close by saying that Hawk Mountain is a really important part of this process. The last talk ended with an example, this survey of the impact of the trainee program. And it really, really is remarkable how many people have been affected and how this has changed the trajectory of their careers and benefited them as individuals and benefited raptor conservation in general. So I think with that, that's pretty much all I wanted to talk about. I'm happy. I will stay on. I'll probably put some headphones on. I'll stay on and be happy to answer questions if people have them. Thanks a lot.
Hi, Todd. This is Sean Grace. I was wondering what your take on how much is, I read that book, The Falcon Thief. It was a fascinating read. I was wondering what your thoughts were on, modern technology, GPSing nest locations and people going and illegally collecting for falconry trade. How much of an impact that's having on
raptors? It's a good question. I think it's something that is a struggle in raptor conservation. Falconers have a history of both the good and the bad, right? Falconry has made a huge contribution to raptor conservation. Falconers really led the charge for the reintroduction, the captive breeding of peregrine falcons, and that was a huge benefit. Falconers are also sometimes bad actors, right? And we have seen falconers who illegally steal birds from nests, capture them, and frankly, the trade in sacred falcons in the Middle East is completely non-sustainable right now. So I think that there are ways to do falconry in sustainable ways, and there are people doing it in sustainable ways, and there are also bad actors out there. And I think that in the long run, what we want to do is probably promote the good actors and try and do what we can to shut down the bad actors. Does that sort of answer your question, Sean?
All right. I think, Todd, we're very cold here.
Okay.
It's not that we don't want to stay and discuss.
That's fine.
Hi, Camille. Yeah. Do you want to? Okay. Yeah.
Hi, Camille.
Speakers today to come up briefly.
Yes, we want to. Yeah. So Ernesto, Jenny, all the speakers who presented today, if you could just come up, we have a small thank you for your time and your energy, for making the travels to Hawk Mountain. We really appreciate it. And of course, another round of applause for these amazing speakers.
Hi, Camille. Thank you so much, Todd, for taking your time at the early morning hours there.
Sure thing. I'll stay on for as long as I can.
The visitor center, which is nice and warm. drinks and food, so please do adjourn after. But thank you to all the speakers. You were great. We're very inspired.